Okay, let's dive into this. Welcome to today's explainer. We talk a whole lot about artificial intelligence and machine learning these days, but we rarely stop to think about the diet we're actually feeding these digital brains, right? Those systems, they're entirely dependent on the data they ingest, the quality, the structure, and really the nuance of that data. That's what dictates exactly how intelligent these systems can actually be. So today, we're exploring the Codatta Protocol and how it addresses a massive blind spot in modern data processing by establishing what we call true hierarchies of intelligence. Not all information deserves equal weight. I mean, it sounds like common sense, right? Think about it. If you're building a massive digital brain, a proven fact, like, say, the freezing point of water, obviously shouldn't carry the exact same influence as some random, unverified internet rumor. Yet, surprisingly enough, this basic logical distinction is exactly where a lot of our current data models fundamentally break down. To really understand the problem here, we have to look at the status quo. On one side, we've got repeated validation. These are your rock-solid signals backed by absolute proof and historical consensus. On the flip side, we have emerging signals, new, developing information that might be incredibly valuable tomorrow, but just isn't proven today. So what's the issue? Well, it's how traditional data sets actually handle this. Imagine taking a bedrock scientific fact and a half-baked internet theory, throwing them both into a massive digital blender and just hitting puree. All that crucial nuance is entirely stripped away, and it just leaves us with this flattened, uniform mush of data. That's inefficient and dangerous. Let's just let that sink in for a second. When you flatten data into one uniform layer, you are effectively blindfolding the system. It's inefficient, for sure, because the system has to work twice as hard to figure out what's actually real. But it's dangerous because it leads directly to AI confidently spitting out incorrect information as if it were absolute gospel truth. If a system literally can't tell the difference between a fundamental fact and a provisional guess, well, the entire foundation of its intelligence is completely compromised. So instead of that flat data mush, Kata methodically build hierarchies. Now, what's really interesting about this is how they approach that tiered structure. The bedrock of high confidence, proven facts, naturally carries the strongest influence at the very base. But here is the brilliant part. The emerging ideas, those lower confidence signals at the top, they aren't just thrown away. They remain entirely visible, but they're clearly marked as provisional. Nothing is discarded, everything is contextualized. You see, it's not about deleting data at all. It's about organizing it with honest, built-in self-awareness. When you contrast the two approaches, the difference is literally night and day. Traditional datasets treat the machine like a messy, flattened storage drive, which effectively just dumbs down the entire learning process. The Codatta Protocol, on the other hand, creates a much richer learning environment. Because everything is properly weighted and given context, the systems interacting with this data can clearly and instantly distinguish between those strong, unshakable foundations and the more open, evolving questions. It treats the machine way more like a discerning student weighing its options rather than just a mindless parrot. Ultimately, the whole shebang comes down to this. Codatta turns raw data into structured judgment. And this brilliantly illustrates what we actually need from AI. Let me repeat that because it's absolutely crucial. Structured judgment. We don't just want systems that can blindly regurgitate raw data. We want systems that actually possess the structured judgment to know exactly how much trust to place in it. By organizing information into these clear contextual hierarchies, Codatta is providing exactly what makes machine intelligence truly reliable in the real world. Which leaves us with this final vital question to ponder. How do the systems you rely on every single day differentiate between strong foundations and open questions? Think about that. The next time you ask an AI a question or rely on an algorithm to make a decision for you, ask yourself, is it pulling from a flattened, dangerous layer of noise or a contextualized hierarchy of intelligence? Because honestly, the difference between those two approaches is the difference between an answer you can just read and an answer you can actually trust. Thanks so much for joining me on this explainer, and keep questioning the data behind the intelligence.